Hi folks, this is a video to accompany your understanding of section 5.8, which is modeling quadratic functions. So the problem that we're going to work on here goes along with example 2 on page 306 of your textbook, which is to write a quadratic equation, pardon that, for the function for the parabola shown below. So when we look at the graph, first of all, it's a quadratic, it's a parabola. What do we have here? Well, we have this random point down here, which is 2 comma negative 6. We also know that we have x-intercepts at 1 and an x-intercept at 4. So I'm going to key in on the fact that we have these x-intercepts at 1 and at 4. So if we have our two x-intercepts, we should probably use intercept form. So if you don't remember what intercept form is, here we go. Y equals a times x minus p times x minus q, where p and q are the x-intercepts. So we said the x-intercepts were at 1 and at 4, so I'm going to substitute in 1 for p and 4 for q. And just like the modeling with the vertex form, we're still left with the fact that we don't know what a is. So this is a similar problem in the fact that we're going to take this other point, 2, negative 6, and I'm going to plug that in for x and for y. So just make sure you plug in the right coordinate into the right variable there. So y is negative 6, a is what I'm looking for, x is 2, so I'm going to have 2 minus 1 here times 2 minus 4. And now I have a single equation with a single unknown, and I can go ahead and solve for a relatively easily. So I'm going to have negative 6 equals negative 2a, and I can divide by negative 2 here. And I can get 3 equals a. At which point you want to, just like we did before, take your value for a and substitute it back into your, really the second equation, where I have my p and q already known, already substituted in. And I can say y equals 3 times x minus 1 times x minus 4. And that's an equation for this parabola shown here. It's not in standard form, but that's not what the question is asking for. So I can leave it just like this without any worries.